For the introduction, resonance of sound is a natural phenomenon when an object or a system vibrates at its natural frequency. When the frequency of the external sound matches the natural frequency of an object, for example glass, it will result an increase in amplitude, creating a resonant effect and finally break the glass. In amusement park, loud music rides could produce sound waves that could potentially match the natural frequency of the glass object, particularly glass cup, and break the glass, which is not desirable. In this project, we are going to determine what factor will affect the natural frequency of the glass cup and suggest type of the glass cup that is more suitable to be used in amusement park. The objective in this project are to identify the relationship between the physical factor with natural frequency of glass and natural frequency sensitivity at empty and full state. Second is to determine the glass cup type, which is natural frequency at least sensitive to the change in water level. Third is to develop a prediction model of natural frequency and sensitivity of glass cup with physical dimension of the glass cup.
According to Hassan Jalali, as the water level increases, the natural frequency of the glass decreases. Therefore, to determine the sensitivity of glass cups towards change in water level, the natural frequencies of the glass cup in empty and full state are tested and recorded. Besides, according to liberal test and step exchange, wall thickness and height will affect the natural frequency of the glass tube. Therefore, these two physical dimensions will be recorded to find their correlation with natural frequency and sensitivity of the glass cup. Moving on, Jasun Yan states that the sensitivity of different size of wine glass to the liquid level is different. Therefore, size of the glass cup, which can be represented by their inner diameter, height, thickness, and volume, are measured and recorded to help us develop a prediction model of how inner diameter, height, thickness, and volume could affect the sensitivity of the glass cup.
We are interested in obtaining the correlation between physical dimension of the glass cup with the natural frequency and the sensitivity of it. Therefore, all the data obtained in the individual open-ended lab, including the natural frequency and the sensitivity, has been to be linked together. Excel software is being used to find correlation between each of these physical dimensions with the natural frequency in the empty state and the full state, and the sensitivity. After that, multiple regression analysis is performed to develop a prediction model for the natural frequency and sensitivity according to the glass type. This will help identify the glass type that is least sensitive, hence more suitable for amusement park setting.
This is an overview of the correlation result between physical dimensions and natural frequency in empty, full state, and sensitivity. We will start with natural frequency in both empty and full states. As mentioned by the previous research, the sensitivity of different size of wine glass to the liquid level is different. It is found that each of the glass type shows a different level of correlation strength between natural frequency and physical dimensions. Taking sensitive glass type as example, it has strong negative correlation with volume, height, volume over inner diameter by height, and thickness over inner diameter, medium negative correlation with thickness, and strong positive correlation with inner diameter. This correlation result tell us that when the volume, height over inner diameter by height, and thickness over inner diameter and thickness of the glass is increased, the natural frequency in empty state will decrease, while increasing the inner diameter of glass cup will increase the natural frequency of it. Whereas for sensitivity correlation, it is found that no particular physical dimension show all positive correlation or all negative correlation with the natural frequency sensitivity, which also observed in the natural frequency in empty and full state. This means that some physical dimension will increase the sensitivity in some glass type while decrease it in another glass type.
Moving to the prediction model of the sensitivity of each glass types, that is tabulated outcome.
It is found that the last two parameters do not affect the sensitivity at all despite they have some correlation in previous analysis, whereas the thickness and inner diameter is not significant in certain glass types. Taking snifter glass as example and using suitable value of physical dimensions, the sensitivity of each glass type toward change in water level can be obtained as below. By letting thickness of the glass 2 mm, volume 200 mm, inner diameter 5 cm and height of the glass by 10 cm. The snifter glass will get about 39% of sensitivity, the beer glass will get about 33.16% of sensitivity, the wine glass will get about 52.15% of sensitivity, and the tumbler glass will get about 34.31% of sensitivity.
In this project, our group has successfully identified the correlation between physical dimensions and natural frequency in empty and full state, and also its sensitivity, and it is found that different glass type has different correlation which align with is consistent and supported by previous research findings. And the glass cup that is least sensitive to change in water level is beer glass cup. Therefore, it is recommended to use beer glass cup in an amusement park setting, regardless of the size of the glass.